press the bell icon on the YouTube app and never miss another update.
Hello children, in the last class we were about to start fundamental theorem of arithmetic, right? That is, today's concept is fundamental theorem of arithmetic, right? Shortcut FTA. What's that? FTA. Before talking about that, let me talk something, some basic things. If I write n as 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, etc. Right? What are those? They are the natural numbers. 1, 2, 3, 4, 5, etc., etc., etc. All are natural numbers, right? Now, I take 2 as my primary thing now. Now tell me, what are the numbers which divide 2? 2 divides 2 completely giving rise to what? 1 as quotient. 1 divides 2 giving quotient 2, right? No other number except 1 and 2 divide 2. That is, 2 as only 2 divisors, they are 1 and 2. Now, let me take 3. Which are all the numbers that divide 3 here? 3 divides by 3 giving quotient 1, remainder 0. 1 divides 3 giving quotient 3, remainder 0. Right? Therefore, is there any other number which can divide 3 here? No. 4 cannot divide 3, 2 cannot divide 3, only 1 and 3 can divide 3. Similarly, I take 5. Now, 5 can be divided by 5 giving quotient 1, remainder 0. Following? Or else 1 can divide 5 giving quotient 5, remainder 0. Only 1 and 5 can divide 5. No one else can. Same time, like that only. 7 can be divided by only 1 and 7. 11, the next number 11 can be divided by only 1 and 7. 1 and 11. 13, only 1 and 13 can divide 13. No other number can. Now, in other words, I take 4, right? 4 can be divided by 4 giving quotient 1, remainder 0. Therefore, I can say that 4 divides 4. 1 can also divide 4 giving quotient 4, remainder 0. Therefore, 1 divides 4. Now, 2 can divide 4, right, giving quotient 2, remainder 0. Remainder 0. Following, I take next number, 6. See, 6 divides 6, giving quotient 1, remainder 0. 1 divides 6, giving quotient 6, remainder 0. 2 divides 6, giving quotient 3, remainder 0. 3 divides 6, giving quotient 2, remainder 0. Therefore, 1, 2, 3, 6, all can divide 6. 1, 4, 2 can divide 4. Like that, I go for next, that is 8. 8 by 8, of course. 8 by 1, yes. 8 by 2, 2 4 is 8, yes. 8 by 4, 4 2 is 8, yes. That is 2 divides 8. Giving quotient 4, remainder 0, or else 4 divides 8 giving quotient 2, remainder 0. Following? Remainder 0. Here, you should have observed all these 2, 5, 7, the next 11, 13, they can be divided by only one and itself. We call such numbers as prime numbers. So, I call these 2, 5, also 3 also, 2, 3, 5, 7, and next comes 11, and next comes 13. All these can be divided by only one and itself, no other can divide. That is, they are prime numbers. Therefore, what are prime numbers? Those are the numbers which have only two divisors, namely 1 and itself. That is it. Whereas the numbers like 4, 6, 8, 9, 10, 12, they can have divisors more than 1 and itself. Right? Therefore, you see 4 has divisor 1 and 4 along with 2. It has 3 divisors. Right? Here 6 has 4 divisors 1 and 6, except 1 and 6, 2 and 3 can also divide 6. Therefore, I call these numbers as, that is 4, 6, 8, 9. These numbers I call them as composite numbers. What are those? Composite numbers. What are these? Prime numbers. Therefore, I can state like this. The numbers which can be divided by 1 and itself. That is it. They are prime numbers. The numbers whose divisors are more than 2. The numbers whose divisors are more than 2. Like here. 1 4 ಬಿಟ್ಟು 2 ಕೂಡ ಡಿವೈಡ್ ಮಾಡುತ್ತೆ. ಹಾಗಾಗಿ 3 ಇದಾವೆ ಡಿವಿಸರ್ಸ್ಗಳು ಇಲ್ಲಿ. ಇಲ್ಲಿ ಎಷ್ಟಿದಾವೆ? 4 ಇದಾವೆ ಡಿವಿಸರ್ಸ್. There are 4 divisors of 6. Right? Therefore, I call these as composite numbers. Therefore, composite numbers are the numbers which has more than 2 divisors. That is, which has divisors other than 1 and itself. ಒಂದು ಮತ್ತು ಅದನ್ನು ಬಿಟ್ಟು ಇನ್ನು ಬೇರೆ ಕೂಡ ಇದ್ದಾವೆ ಡಿವಿಸರ್ಸ್ಗಳು. ಅವನ್ನ ನಾವೇನಂತೀವಿ? ಕಂಪೋಸಿಟ್ ನಂಬರ್ಸ್ ಅಂತೀವಿ. ಇವೇನಂತೀವಿ? ಪ್ರೈಮ್ ನಂಬರ್ಸ್. ಬಟ್ ಐ ಲೆಫ್ಟ್ 1 ಇಯರ್. ಇದ್ರ ಮಾತ್ರ ತಗೊಳ್ಳಿಲ್ಲ. Now let me take that 1. 1 divides 1, agree. 1 divides 1 giving quotient 1, remainder 0. Now, is there any other number which can divide 1? No. If I want to say 1 as prime number, it has to have at least 2 divisors. 1 and itself. That is 1 and itself. Itself means that nothing but what? 1 only, right? Therefore, it has only 1 divisor. That is 1 only, no 2 divisors. All prime numbers have 2 divisors, 1 and itself, whereas 1 has only 1 divisor, that is only 1. That is why I cannot group that into prime numbers. Now, coming to composite numbers, what are they? They are having more than 2 divisors. Apart from 1 and themselves, they have other divisors also. Here only one has only 1 as divisor. Therefore, I cannot make it as a composite number. I cannot make it as composite number, or I cannot group it as composite number. I cannot group it as prime number. Therefore, I can call that it is neither prime nor composite. Which one? 1. You already learned these things in the earlier class. I just recalled it, right? Now I come to the point. So you know what are the composite numbers, prime numbers, right? So I rub this. Now I am coming to the point. Let me take a number that is 250. You know, 250. The number 250, no, what is that number? It is a composite number. Why so? Because it has 1 and 250 as its divisors. Along with that, there are many divisors for 250. Following ఎంత number is 50. 250 is a number which has divisors. 1 can divide 250, 250 can divide 250. Along with that 2 can divide 250. Following 2 can divide 250 giving quotient 125. 5 can divide 250 giving quotient how much? How much? 50, right? 5 can divide 250 giving quotient 50. 5 50s are 250. Remainder 0. Therefore 5 can divide 50. Sorry, 250. 50 can divide 250. That is 50. 250. How many times? 5 times. That is 0. So apart from 1 and itself, it has other divisors. Therefore I can say it is a composite number. Now I write like this. 250 as 2 into 5 into 25. ತಪ್ಪೇನಪ್ಪ ಇಲ್ಲಲ್ವಾ? ಎರಡೆಲ್ಲ 10 ಅದು 25 250. For this and this is one and same, right? Now I used these numbers 25, 5 and 2 with some operation that is multiplication, and I made 250 and I made 250. Now can I say that these are the factors? Yes, these are the factors of 250 because using these only I made out 250. I made out 250. Therefore these three are the factors of 250. Now what if I write like this? 2, 5, 5, 5. That is I grouped or I just differentiated 25 into 5 into 5. Now tell me, are all these factors of 250? Yes, they are the factors of 250 because using these 4 numbers only I got 250. It's a multiplication process. Following? Therefore I can call these as factors. But here I call them by name, that is prime factors. That is prime factors. Now tell me, is 2 prime number? S2 is prime number. 5 prime number. S prime number. This is prime. This is prime. 25. No, it is not a prime number. Along with 1 and 25, 5 can also divide 25. Therefore it has 3 divisors. It's a composite number. It's a composite number. Now here prime, 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 all are prime numbers. Any number can be expressed as product of its factors, which in turn can be turned down into product of only prime factors. Product of only prime factors. Therefore 250 I wrote it as product of prime numbers only or prime factors only. Followed? Now I take your textbook example. What are they saying? 1771. 1771. I write it like this. Do the multiplication of 77 and 23, you will get 1771. Now can I call those 77 and 23 as the factors of 1771? Yes, I have to call that. Right? These are the factors of, simply they are factors of 1771. These are the factors of 250. These are the prime factors of 250. Why so? Because this expression, this expansion to 525 contains both prime and composite. Whereas this expression, this expansion, 2555, this contain only prime numbers or prime factors. These are just factors, these are prime factors. Now look here, these are just factors of 1771. Right? Why so? Because maybe this is prime, but this is composite number. Why so? Along with 1 and 77, 11 can divide 77. Following? Or else 7 can divide 77. Therefore it is a composite number. So these are just factors only. Now what if I turn them like this? 7, 11, 23, 1771. Following? Here, see, I just made out 1771 by using three numbers known as 7, 11, 23 and also operation multiplication, right? Multiplication operation. Now, I got 1771. Can I call these as factors? Yes, I have to call that. But I call them as prime factors. Yes, of course. Why so? Because these are the prime numbers. These are the prime numbers. Therefore, a composite number, 1771 is a composite number. Why so? Because it is divided by 1 and 77 along with 1 and 1771. 77 divides it, 23 divides it, therefore it has more than 2 divisors. It has divisors apart from 1 and itself. 1 ಮತ್ತು 1771 ಬಿಟ್ಟು ಬೇರೆ ಬೇರೆ ನಂಬರ್ಗಳು ಕೂಡ ಅದನ್ನು ಡಿವೈಡ್ ಮಾಡುತ್ತೆ, ಹಾಗಾಗಿ ಅದು ಕಂಪೋಸಿಟ್ ನಂಬರ್. ಇಲ್ಲಷ್ಟೇ 1 ಮತ್ತು 250 ಬಿಟ್ಟು ಬೇರೆ ಬೇರೆ ನಂಬರ್ಗಳು ಕೂಡ ಅದನ್ನು ಡಿವೈಡ್ ಮಾಡುತ್ತೆ, ಹಾಗಾಗಿ ಇದು ಕಂಪೋಸಿಟ್ ನಂಬರ್. ಸೊ ದಿಸ್ ಕಂಪೋಸಿಟ್ ನಂಬರ್ ಜಸ್ಟ್ ಐ ಎಕ್ಸ್ಪ್ರೆಸ್ಡ್ in the form. In the what form? In the multiplication form of some prime numbers. So I call this as prime. I call these as prime factors. I take one more example. What is that? 5313. 5313. I can write it as 21, 11, 23. Do the multiplication of these three. That is 21, 11, 23. You get this 5313. Now tell me, are they just factors or are they prime factors? This is a prime number, I know. This is a prime number, I know, because they have only 1 and itself only as divisors. Here, 21 is not a prime number because along with 1 and 21, 3 can divide 21, 7 can divide 21. Therefore, it is a composite number. Therefore, all these are just factors of what? 5313. But what if I turn this as like this? 3, 7, 11, 23. Now tell me, in this expansion, is there any composite number? No. No composite number. No composite number, only prime numbers are there. Therefore, these are the prime factors of 5313. This 5313 is a composite number. Now, take any composite number like this. Take any composite number like this and you can just write that composite number in the form of multiplication of prime numbers. Of only prime numbers, not using even a single composite number. You can write for any composite number. Take 12, a simple composite number, a small composite number, right? Relatively. Now I can write it as 2 into 6, I know, 2 into 6 is 12. Now this is prime number, this is composite number, these are just factors of 12. Now what if I write like this, 2 into 2 into 3, 12. Now tell me, what are these? These are the prime factors of 12, right? Prime factors of 12. Now, any composite number, whether it is small or big or the biggest of biggest, it can be expressed as product of prime numbers, product of prime numbers, product of prime numbers, any composite number. If you ask me a question like this, sir, can you produce all the composite numbers? I produced a composite number 1771 using multiplication of some prime factors or prime numbers. I produced 250 by multiplying some prime numbers, right? Like that only. So can I produce all the composite numbers? There are infinitely many composite numbers. See, in the natural numbers 1, 2, 3, 4, 5, 6, 7, no? There are many composite numbers, infinitely many composite numbers. If you ask me a question, can all those composite numbers can be produced like this or in this way? Yes, we can say it is. It is possible. We can produce any composite number, any, say 5000. I know 5000 is equals to what and what? 2 into 2500 or else 2 into 25 into 100. Just factors. Now what if I write like that? 2 into 5 into 5, 10 into 10 ಬರೀತೀನಪ್ಪ ಈಗ. ಅರ್ಧಾ ಇಲ್ಲಿವರೆಗೂ ಮಾತ್ರ, ರೈಟ್? ಇದು ಬೇರೆ. ಇದು ನೋಡಪ್ಪ ಇಲ್ಲಿ 2 ಇಂಟು 5 ಇಂಟು 5, 10 ನಾನು 2 ಇಂಟು 5 ಬರೀತೀನಿ, ಇನ್ನೊಂದು 10 2 ಇಂಟು 5 ಬರೀತೀನಿ. ಇವೆಲ್ಲವೂ ಮಲ್ಟಿಪ್ಲೈ ಮಾಡು, 5000 ಬಂದೇ ಬರುತ್ತೆ. ಈಗ ನೋಡ ಸುಮ್ಮನೆ ಅರೇಂಜ್ ಮಾಡ್ತೀನಿ ಅಷ್ಟೇ. 2 2 2 ಇಲ್ಲೇನಿದೆ 5 5 5 5 4 5s and 3 2s. Following? See here? Only prime numbers. Using the multiplication or just I produced a number 5000, a composite number, by multiplying the prime numbers only. Prime numbers only. Therefore, I can produce every composite number that can exist in this way. In what way? Product of prime numbers. This is known as FTA, Fundamental Theorem of Arithmetic. What it says? Simple. Fundamental Theorem of Arithmetic says that or states that every composite number can be expressed or can be written or can be factorized. Hello, can be expressed, can be factorized, can be written as the product of prime numbers. Product of prime numbers, and it is unique. This product, no, this is unique. This factorization is unique. Now, to make some understanding of the term unique, I take an example in particular. ಎಂತ an example ಇದು. I hope it is clean. Say 125, right? 5 gives you 125. Prime factorization, product of only prime numbers, right? Now tell me, can I bring any other prime number in a place of 1 5 such that I can make out 125? ಅಂದರೆ ಈ 5ರ ಜಾಗದಲ್ಲಿ ಇನ್ನೊಂದು ಯಾವ್ದಾರು 7 ತಂದು ಹಾಕಿದ್ರೆ ಬಂದ್ಬಿಡುತ್ತಾ 125? ನೋ ಚಾನ್ಸ್, ಬರೋಕ್ಕೆ ಚಾನ್ಸೇ ಇಲ್ಲ. These are the only prime numbers that I can make use of to make this 125. No other prime number can help me here to make 125. Following? Take 7000. 2 into 3500, correcta? Now into 100 ಬರೀತೀನಿ, ಕರೆಕ್ಟಾ? What are these? Only factors of prime, composite, therefore only factors only. Therefore now 2 into 5 7 35, 10 as 10 into 10. Now 2 into 5 into 7 into 2 into 5 gives 10, 2 into 5 gives 10. Following? Now I write in order wise: 2 2 2 5 5 5 7 3 7, right? Now tell me, I can use 2 5 7. I used 2 thrice, 2 into 2 into 2. I used 5 thrice, 5 into 5 into 5. I used 7 only one time. With some multiplication, I got 7000. This is prime factorization, right? Right? These are all the prime factors of 700. Now, instead of 2 5 7, can I use any other prime number? Say 11, say 13, say 17, say 23. If I bring any other prime number in place of any of these numbers, I cannot make out 70010. That is 7000. I cannot produce 7000 by other prime numbers. I have to use only these 3 numbers, or else it can be expressed as product of these prime numbers only. No other prime number can help me. That's why it is unique. It is unique, a single form, a particular form. ಅದು ಹೆಂಗೆ ಹೇಳ್ತೀರಿ ಸರ್? ನಾನು ಹಿಂಗೆ ಬರ್ಬಿಡ್ತೀನಿ, ಫಸ್ಟ್ 5 ಹಾಕ್ತೀನಿ, ಆಮೇಲೆ 7 ಹಾಕ್ತೀನಿ, ಆಮೇಲೆ 2 ಹಾಕ್ತೀನಿ, ಲೈಕ್ ದಿಸ್. 5 ಹಾಕ್ತೀನಿ, 5 ಹಾಕ್ತೀನಿ, 5 ಹಾಕ್ತೀನಿ, ಆಮೇಲೆ 2 ಹಾಕ್ತೀನಿ, ಆಮೇಲೆ 7 ಹಾಕ್ತೀನಿ, ಆಮೇಲೆ ಲಾಸ್ಟ್ ಮತ್ತೆ 2 ಹಾಕ್ತೀನಪ್ಪ. ಡಿಫ್ರೆಂಟ್ ಅಲ್ವಾ? ನೋ, ಇಟ್ಸ್ ಜಸ್ಟ್ ಒನ್ ಆ್ಯಂಡ್ ಸೇಮ್. ಮೇ ಬಿ ಯು ಚೇಂಜ್ಡ್, ಮೈಟ್ ಬಿ ಯು ಚೇಂಜ್ಡ್ ಆರ್ಡರ್ ಆಫ್ ದೀಸ್ ನಂಬರ್ಸ್. ಫಸ್ಟ್ 5 ಬರ್ದಿ ಆರ್ಡರಲ್ಲಿ, ಆಮೇಲೆ 2 ಬರ್ದೆ, ಮತ್ತೆ 2 ಬರ್ದೆ, ಆಮೇಲೆ 7 ಬರ್ದೆ. ಇಟ್ ಡಸಂಟ್ ಮ್ಯಾಟರ್ ಹಿಯರ್. ಇಟ್ಸ್ ಒನ್ ಆ್ಯಂಡ್ ಸೇಮ್. ವಿ ಟೇಕ್ ದೀಸ್ ಥಿಂಗ್ಸ್ ಆಸ್ ಒನ್ ಆ್ಯಂಡ್ ಸೇಮ್. Right? Maybe the order of numbers is different here, but they are one and same, no? We have to use only 3 2s, 3 5s, 1 7, 3 5s, 3 2s, 1 7. This is one and same. That is prime factorization. What's that? Prime factorization. Prime factorization of any composite number is unique. ಅಂದರೆ ಆ ನಂಬರ್ಗಳನ್ನು ಮಾತ್ರ ಯೂಸ್ ಮಾಡಿ ಈ ನಂಬರನ್ನು ಫಾರ್ಮೇಷನ್ ಮಾಡ್ಬೋದು. ಯಾವುದೇ ಇನ್ನದರ್ ನಂಬರನ್ನು ತೊಗೊಂಡು ಮಾಡೋಕ್ಕಾಗಲ್ಲ, ಇನ್ನು ಯಾವುದೇ ಪ್ರೈಮ್ ನಂಬರ್ ತೊಗೊಂಡು ಮಾಡೋಕ್ಕಾಗಲ್ಲ, ಇದೇ ಪ್ರೈಮ್ ನಂಬರ್ ತೊಗೊಂಡು ಮಾಡಬೇಕು. ನಾನು ಇದನ್ನೇ ಮಾಡ್ತೀನಿ, ಈ 2 3 ಸರಿ 5 3 ಸರಿ 7 1 ಸರಿ ಇದೆ ಅಲ್ವಾ, ಅದು ಈಗ ಬರೀತೀನಿ ಅಷ್ಟೇ. 2 3 ಸರಿ 5 3 ಸರಿ 7 1 ಸರಿ, ಅದು ಕೂಡ ಪ್ರೈಮ್ ಫ್ಯಾಕ್ಟರೈಸೇಷನ್ನೇ. ಸೊ ಜಸ್ಟ್ ರೈಟಿಂಗ್ ಫಾರ್ ಲಾಂಗ್ ಲೆಂತ್, ನೋ ಫಾರ್ ಮೋರ್ ಲೆಂತ್, ಐ ಜಸ್ಟ್ ಕಾಂಟ್ರಾಕ್ಟ್ ಇಟ್, ರೈಟ್? ಐ ಜಸ್ಟ್ compressed like this, using some powers here, using some powers. 2 3 5 3 7 1. So product of powers of prime ಅಷ್ಟೇ ಇದು. product of primes, product of powers of primes ಅಂದರೆ ಪ್ರೈಮ್ ನಂಬರ್ನ ಪವರ್ಸಲ್ಲಿ ಇಟ್ಟಿದ್ದೀನಿ, ಜಾಗ ಸೇವ್ ಮಾಡಲಿಕ್ಕೆ, ಸಿಂಪಲಾಗಿ ಕಾಣಲಿಕ್ಕೆ. ಎರಡು ಒಂದೇ, ಇದು ಒಂದೇ, ಇದು ಒಂದೇ. Therefore any composite number can be expressed as product of primes or product of powers of primes. Can be expressed as product of primes or product of powers of primes. Nothing but what? FTA, fundamental theorem of arithmetic. And this expansion or this factorization is unique. It is unique. We cannot make out other form here. Else we cannot use any other prime numbers to make 70010. We have to use these 257 only to make out 7000. To make out 7000. That's why FTA explains that or can be stated as like this. I am going to state it. Before that, I just do one more example given in your textbook to avoid confusion, right? Large number, ಒಂಚೂರು ದೊಡ್ಡದಿದೆ, 3 2 7 6 0, 37,760. ಇದನ್ನ ಪ್ರೈಮ್ ಫ್ಯಾಕ್ಟರೇಷನ್ ನಿಮಗೆ ಮಾಡೋದು ಗೊತ್ತಿದೆ. ಫ್ಯಾಕ್ಟರ್ ಟ್ರೀ ಅಂತಂದು 9th ಕ್ಲಾಸಲ್ಲಿ 8th ಕ್ಲಾಸಲ್ಲಿ ಕಲ್ತಿರ್ತೀರಿ. ಹೆಂಗೆ ಮಾಡ್ತೀನಪ್ಪ? 2 ಫಸ್ಟ್ ಪ್ರೈಮ್ ನಂಬರ್ ಯಾವುದು? 2. 2 ಮಾಡ್ತೀನಿ ನೋಡಪ್ಪ ಇಲ್ಲಿ. 2 16 2 3 2 8 1 ಕರೆಕ್ಟ್ ಮಾಡಿ ನೋಡ್ರಿ. ಈಗ ಮತ್ತೆ ನೆಕ್ಸ್ಟ್ 2 2 8 2 1 2 9 0. ಈಗ ಮತ್ತೆ 2 ಮತ್ತೆ 2ರಿಂದ ಹೋಗುತ್ತಲ್ವಾ, ಹಾಗಾಗಿ 2 ಯೂಸ್ ಮಾಡ್ಬೇಕು ನಾನು. 2 4 ಹೋಗಲ್ಲ, 2 9 18 1 2 5 ಕರೆಕ್ಟಾ? ಮತ್ತೆ 2ರಲ್ಲಿ ಹೋಗಲ್ಲ, 3ರಲ್ಲಿ ಹೋಗುತ್ತಾ? ಹೆಂಗೆ ಹೋಗುತ್ತೆ? 9 5 14 14 18 1 + 8 9. If you just count or if you just add all the digits of this number, it has to be the multiple of 3, then only 3 can divide this number. I say it can divide by, can be divided by 3. Therefore 3 1 ja 1 ಉಳಿತು, 3 3 ja 9, 1 ಉಳಿತು, 3 6 18 1 3 15 4 10 15 can be divided by 3. Therefore this number should be divided by 3. ಮತ್ತೆ 3ರಿಂದ ಮಾಡ್ತೀನಿ ನೋಡಿ. 3 4 12 1 3 15 1 3 15 9 4 15 ಬರಲ್ಲ ಇಪ್ಪ ನೋಡಿ. 5 4 9 9 5 14 14 cannot be divided by 3, cannot be by 3. Therefore 3 ಇಂದ ಆಗಲ್ಲ. 4 is not a prime number. I have to go for another number, that is 5. The next prime number 5 9 ಚಿ 1 ಜ ಫಾಲೋವಿಂಗ್. 5 ಮತ್ತು 45 5 ಮತ್ತು 5. ಈಗ ನೋಡಪ್ಪ, 5ರಿಂದ ಹೋಗಲ್ಲ, 6ರಿಂದ ಮಾಡೋಂಗಿಲ್ಲ, 7ರಿಂದ ನೋಡೋಣ, 7 13 13 91 ಅಲ್ವಾ, 7 13. ದಟ್ಸ್ ಇಟ್. ಸಿ ಹಿಯರ್, multiply all these, we get 32760. So using factor tree, you can just find the prime factors of any composite number, right? Take any other big composite number. Only the difference is the process will be continuous and it is time taking, that's it. So you can easily say that, or you can come to the conclusion that every composite number can be expressed as product of prime numbers. That's it only, that's it, that is FTA, right? Now ಈಗ ನೋಡಪ್ಪ, FTA ಸ್ಟೇಟ್ಮೆಂಟ್ ರೂಪದಲ್ಲಿ ಡಿಫೈನ್ ಮಾಡಿಬಿಡ್ತೀನಿ, ಯಾಕಂದರೆ ಕೇಳ್ತಾರೆ ಎಕ್ಸಾಮಲ್ಲಿ ಕೇಳ್ತಾರೆ, ರೈಟ್? ಎವ್ರಿ ಕಂಪೋಸಿಟ್ ನಂಬರ್ can be expressed or factorized, ಎಲ್ಲ ಒಂದೇ, factorized or written as the product of prime numbers. Product of prime numbers. Sometimes the product of powers of prime. ದೊಡ್ಡ ನಂಬರ್ ಇದ್ದರೆ ಭಾಳಷ್ಟು ಎರಡು ರಿಪೀಟ್ ಆದನಪ್ಪ ಅಂದ್ರೆ ಅದನ್ನ ಪವರ್ ರೂಪದಲ್ಲಿ ಬರಿತೀವಿ, 5 ರಿಪೀಟ್ ಆದರೆ ಅದನ್ನ ಪವರ್ ರೂಪದಲ್ಲಿ ಬರಿತೀವಿ, ಅಷ್ಟೇ ಅರ್ಥ ಅಲ್ಲಿ. ಪ್ರಾಡಕ್ಟ್ ಆಫ್ ಪವರ್ಸ್ ಆಫ್ ಪ್ರೈಮ್ಸ್ ಆರ್ ಪ್ರೈಮ್ ನಂಬರ್ಸ್ and it is unique. ಹಂಗೆ ಮಾತ್ರ ಮಾಡೋಕ್ಕೆ ಸಾಧ್ಯ, ಬೇರೆ ರೂಪದಲ್ಲಿ ಬರೆಯೋಕ್ಕೆ ಸಾಧ್ಯನೇ ಇಲ್ಲ. ಅಪಾರ್ಟ್ ಫ್ರಮ್ ಆರ್ಡರ್, ಅಂದರೆ ನಂಬರ್ಸನ್ನು ಆರ್ಡರ್ ವೈಸ್ ಹಂಗೆ ಬರ್ದೆ ಹಿಂಗೆ ಬರ್ದೆ ಅದನ್ನು ಹೊರತುಪಡಿಸಿದ್ರೆ ದಟ್ ಎಕ್ಸ್ಪ್ಯಾನ್ಷನ್ ಈಸ್ ಯುನಿಕ್. ಅಪಾರ್ಟ್ ಫ್ರಮ್ ದಿ ಆರ್ಡರ್ in which you write them, technically I can write like this, in which prime numbers occur ಅಂತ ಬರಿತೀನಿ ಅಷ್ಟೆ. ಅಂದರೆ ಯಾವ ಆರ್ಡ್ರಲ್ಲಿದ್ದಾವೆ ಅನ್ನೋದನ್ನು ಬಿಟ್ಟರೆ, ಅದನ್ನು ಹೊರತುಪಡಿಸಿದರೆ ದಟ್ ಎಕ್ಸ್ಪ್ರೆಷನ್, ದಟ್ ಎಕ್ಸ್ಪ್ಯಾನ್ಷನ್, ದಟ್ ಫ್ಯಾಕ್ಟರೇಷನ್ ಈಸ್ ಯುನಿಕ್. ಬೇರೆ ಯಾವ ನಂಬರ್ ತೊಗೊಂಡು ಬಂದು ರಿಪ್ಲೇಸ್ ಮಾಡಿ ಮಾಡೋಕ್ಕಾಗಲ್ಲ, ಅಷ್ಟೇ ಅರ್ಥ. Following, in simple words, prime factorization of a composite number is unique. Prime factorizer, that is, if you just write a number, composite number in the form of prime numbers, in the form of product of prime numbers, it should be unique. It will be unique ಆಗಿದ್ದೇ ಇರುತ್ತೆ. So that's the only form in which you can write that. ಬೇರೆ ಯಾವ ಫಾರ್ಮು ಸಿಗಲ್ಲ. ಈಸ್ ಯುನಿಕ್. ಅಪಾರ್ಟ್ ಫ್ರಮ್ ದಿ ಆರ್ಡರ್, ಅದೇ ಆರ್ಡರ್ ಬಿಟ್ಕೊಂಡು ನಂಬರ್ಸ್ ಇರ್ತಾವಲ್ವ, ಫಸ್ಟ್ ಅದನ್ನ ಹಾಕಿದೆ, ನೆಕ್ಸ್ಟ್ ಇದನ್ನ ಹಾಕಿದೆ, ಅದನ್ನು ಬಿಟ್ಟನಪ್ಪ ಅಂದರೆ ಯುನಿಕ್ ಆಗಿರುತ್ತೆ. ದಟ್ ಈಸ್ ಅಪಾರ್ಟ್ ಫ್ರಮ್ ದಿ ಆರ್ಡರ್ ಇನ್ ವಿಚ್ ಯು ರೈಟ್ ದೆಮ್. ಆರ್ಡರ್ ಅಷ್ಟೇ ಸಾಕು. ಇಲ್ಲಿ ನಾನು ಕಂಪೋಸಿಟ್ ನಂಬರ್ ಅಂತ ಹೇಳಿದ್ದೇನೆ, ಬಟ್ ಆ್ಯಕ್ಚುಲಿ ಇಟ್ ಸೇಸ್ ದಟ್ ಪ್ರೈಮ್ ಫ್ಯಾಕ್ಟರೈಸೇಷನ್ ಆಫ್ ಎ ನ್ಯಾಚುರಲ್ ನಂಬರ್, ಆಫ್ ಎನಿ ನ್ಯಾಚುರಲ್ ನಂಬರ್ ಅಂತ ಹೇಳ್ತಾರೆ. ಅಂದರೆ ಪ್ರೈಮ್ ನಂಬರ್ಸ್ ಕೂಡ ಹೇಳ್ಬೋದಿಲ್ಲ ನಾವು. ಸಪೋಸ್ ಲೆಟ್ ಮಿ ಟೇಕ್ ಅ ಪ್ರೈಮ್ ನಂಬರ್ 17. ಹೌ ಕ್ಯಾನ್ ಐ ರೈಟ್ ಆರ್ ಹೌ ಕ್ಯಾನ್ ಐ ಫ್ಯಾಕ್ಟರೈಸ್ ದಿಸ್ ಪ್ರೈಮ್ ನಂಬರ್ ಯೂಸಿಂಗ್ ಪ್ರೈಮ್ ನಂಬರ್ ಓನ್ಲಿ? ಬೈ ಓನ್ಲಿ ಒನ್ ವೇ, 17 ಓನ್ಲಿ. 19 ತಗೊಳಪ್ಪ, 19 is a prime number. This is the only way I can make out, or I can just bring out the factorization of 19. The factorization process ends here only. Right? That is, any prime number, if it is factorized as product of prime numbers, only prime factor that can occur is itself only. Following? So that's why we can just say 21, 3 7s are 21, right? Prime. Composite number can be expressed as product of prime numbers, FTA. A prime number can also be expressed as product of prime numbers. So there is no product, no, here only single number is there. Here two numbers, okay, we can say product is there. Here only single number is here, no product. So don't use this, what is that, sir? This statement, but still we can do that, assuming that there is 1 here. But again you might ask a question here. What's question? Sir, 1 is not a prime number. you have told that 17 or any number, if it is prime factorized, all the numbers should be prime numbers. All should be prime numbers. Here, one is neither prime nor composite number. That's why I cannot write 1 here. So the prime factorization of a prime number is just itself only. So using this or just now taking this as into account, I can write it as prime factorization of any natural number. But more technically, if you just make some more sense, we have to write it as composite number. Followed, children? So ಹಾಗಾಗಿ ಯಾವುದೇ ಕಂಪೋಸಿಟ್ ನಂಬರ್ ಅನ್ನು ಪ್ರೈಮ್ ನಂಬರ್ಸ್ನ ಒಂದು ಪ್ರಾಡಕ್ಟ್ ಆಗಿ ಎಕ್ಸ್ಪ್ರೆಸ್ ಮಾಡ್ಬೋದು. ಆ್ಯಂಡ್ ದಟ್ ಎಕ್ಸ್ಪ್ರೆಷನ್ ಈಸ್ ಯೂನಿಕ್ ಕ್ಯೂ. ಬೇರೆ ಯಾವ ನಂಬರನ್ನ ಅಲ್ಲಿ ತಂದು ಹಾಕೋಕ್ಕಾಗಲ್ಲ. ಸೊ ಆ ನಂಬರ್ಸ್ಗಳನ್ನ ಮಾತ್ರ ಯೂಸ್ ಮಾಡಿಕೊಂಡು ಮಾಡ್ಬೋದು. ಸೊ ದಟ್ಸ್ ದ ಹೋಲ್ ಸ್ಟೋರಿ ಆಫ್ FTA. ನಾವು ಈಗ ನಾನು ಒಂದು ಎಕ್ಸಾಂಪಲ್ ಬರ್ತೀನಿ. ದಿಸ್ FTA, ದಿಸ್ ಫಂಡಮೆಂಟಲ್ ಥಿಯರಮ್ ಆಫ್ ಅರಿಥಮೆಟಿಕ್, ದಿಸ್ ಹ್ಯಾಸ್ ಮೆನಿ ಅಪ್ಲಿಕೇಶನ್ಸ್, ನಾಟ್ ಓನ್ಲಿ ಇನ್ ಮ್ಯಾಥ್ಸ್ ಫೀಲ್ಡ್, ಇನ್ ಅದರ್ ಫೀಲ್ಡ್ಸ್ ಆಲ್ಸೋ. ಬಟ್ ನಿಮಗೆ ಇದೆಲ್ಲ ಬೇಕಾಗಲ್ಲ, ಓವರ್ ಆಗುತ್ತೆ. ಸೊ ನಿಮ್ಮ ಕ್ಲಾಸಿಗೆ ಏನಿದೆ ಅಷ್ಟು ಮಾತ್ರ ನಾವು ಡಿಸ್ಕಸ್ ಮಾಡೋಣ. ಸೊ ಟು ಅಂಡರ್ಸ್ಟ್ಯಾಂಡ್ ದಿಸ್ FTA ಆಸ್ ಅಪ್ಲಿಕೇಶನ್ಸ್ ಇನ್ ಮ್ಯಾಥ್ಸ್, ಲೆಟ್ ಮಿ ಯೂಸ್ ಅನ್ ಎಕ್ಸಾಂಪಲ್. ದಟ್ ಈಸ್ ಟೆಕ್ಸ್ಟ್ ಬುಕ್ ಎಕ್ಸಾಂಪಲ್, ಬೇರೆ ಯಾವುದಲ್ಲ, ಅದರ ಕೊಟ್ಟಿರೋದೇ ಮಾಡ್ತೀನಿ. ಏನಂತ ಹೇಳ್ತಾರವ, ಏನಂತ ಹೇಳ್ತಾರೆ, ಹಿಂಗೆ ಹೇಳ್ತಾರೆ. If the number 4n, sorry, example 5, consider the numbers, ಈ ನಂಬರ್ಗಳನ್ನು ಕನ್ಸಿಡರ್ ಮಾಡಿ. ಯಾವ ನಂಬರನ್ನು? 4n ನಂಬರ್ಸ್ಗಳನ್ನು, where n is some natural number, where n is nat number, simply natural number. ಏನು ಹೇಳ್ತಾರೆ, ನಂಬರ್ ಚೆಕ್ ವೆದರ್ there is any value of n for which 4n ends with 0 digit, ends with the digit 0. ಏನು ಹೇಳ್ತಾರೆ ಅವರು? ಕ್ವಶನ್ ನೋಡ್ಕೊಳ್ಳಿ. ರೈಟ್, ವಾಟ್ ದ ಕ್ವಶನ್? ಕನ್ಸಿಡರ್ ದಿ ನಂಬರ್ಸ್ 4n. ಕೆಲವೊಂದು ನಂಬರ್ಗಳಿದ್ದಾವೆ, 4n ಅಂತ ನಂಬರ್ಸ್ಗಳಿದ್ದಾವೆ. ನಾಟ್ ಓನ್ಲಿ ಕೆಲವು, ದೇರ್ ಆರ್ ಮೆನಿ ನಂಬರ್ಸ್, ಇನ್ಫಿನಿಟ್ಲಿ ಮೆನಿ ನಂಬರ್ಸ್. ವೇರ್ n ಈಸ್ ನಮ್ಮ ನ್ಯಾಚುರಲ್ ನಂಬರ್. ಚೆಕ್ ವೆದರ್ ದೇರ್ ಈಸ್ ಎನಿ ವ್ಯಾಲ್ಯೂ ಆಫ್ n ಫಾರ್ ವಿಚ್ 4n ಎಂಡ್ಸ್ ವಿತ್ 0 ಡಿಜಿಟ್. ಅಂದರೆ ಏನರ್ಥ, 4n ನಂಬರ್ಸ್ ಅಂದ್ರೇನು, n ಅಂದ್ರೇನು, ನ್ಯಾಚುರಲ್ ನಂಬರ್ ಅಂತ ಅವರೇ ಕೊಟ್ಟಿದ್ದಾರೆ. ಇಫ್ ಐ ಪುಟ್ n equals to 1 2 3 4 5 dash 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 like that, I get many numbers here. 4 1, if n equals to 1, the number is 4. n equals to 2, it is 16. 3 64 ಬರುತ್ತೆ ನೋಡಿ, ಮಾಡಿರ್ಬೇಕಾದ್ರೆ. 4 cube is 64. 4 4 is 256. 4 5 is 1024. ಹೀಗೆ ಮಾಡ್ತಾ ಹೋದೇನಪ್ಪ ಅಂದರೆ I get many numbers, infinitely many numbers. What are they asking? Is there any value of n? ಅಂದರೆ ಈ ಥರ n ವ್ಯಾಲ್ಯೂ ಆಗ್ತಾ ಹೋದಾಗ I get a number, right? Such that number should end with 0. ಅಂದರೆ ಕೊನೆಗೆ 0 ಇರಬೇಕು ಅಂತ ಕೇಳಿದ್ದಾರೆ. Here, if you look here with some common sense, no number is ending with 0 here. Even though if I go do, even though if I just go there and do the process continuously for all the natural numbers, I get many numbers like this, who are called as 4n numbers. What are these? 4n numbers. Put value of n 1 2 3 4 5 6, you get those numbers, and none of the number is ending with 0. Looking at this, you can tell like that, but you can also tell, or you can also tell without doing all these process. ಅಂದರೆ ಇಷ್ಟು ಮಾಡ್ದೇನೆ ಹೇಳ್ಬೋದು ನಾವು, ಯೂಸಿಂಗ್ FTA. ಸೊ ಬಿಫೋರ್ ಸಾಲ್ವಿಂಗ್ ದಿಸ್, ಐ ನೀಡ್ ಟು ಡಿಸ್ಕಸ್ ಸಮಥಿಂಗ್. ಇದಿರಲಿ, ಬೇಕಾಗುತ್ತೆ. ಏನಪ್ಪ ನೋಡಿ, ಇದು ನಾನು ಹೇಳ್ತೀನಿ ತಿಳ್ಕೊಳ್ಳಿ. ಈಸ್ 221 ಕ್ಯಾನ್ ಬಿ ಡಿವೈಡೆಡ್ ಬೈ 12? 12 221 ಭಾಗಿಸುತ್ತಾ ಈಸ್ can 12 divide 221? Is 221 can be divided by 12? ನೀವು ಹೇಳ್ತೀರಿ ನೋಡಿದ ತಕ್ಷಣ ಸ್ವಲ್ಪ ನಿಮಗೆ ಒಂದು ಎಕ್ಸ್ಪೀರಿಯನ್ಸ್ ಆಗಿರುತ್ತೆ, ಯು ಹ್ಯಾವ್ ಸಮ್ ಗುಡ್ ನಾಲೆಜ್ ಆಫ್ ಮ್ಯಾಥಮೆಟಿಕ್ಸ್ ಇನ್ ದ ಪಾಸ್ಟ್, ಸೊ ಯೂಸಿಂಗ್ ದಟ್ ಯು ಕ್ಯಾನ್ ಟೆಲ್ ದಟ್ no 12 cannot divide 221. So I just say like this, what are the prime factors of 12? If I just write 12 as 2 3 3, so these are the prime factors of 2 3 is 6, not 2 2 2, 2 2 is 4, 4 3 is 12, that's it. So 2 and 3 are the prime factors of 12, where 2 comes twice, 3 comes only once. ಎರಡು ಸರಿ ಬರುತ್ತೆ, 3 ಒಂದು ಸರಿ ಬರುತ್ತೆ. ಹಾಗಾಗಿ 2 ಮತ್ತು 3 2 and 3 ಆರ್ ದಿ ಪ್ರೈಮ್ ಫ್ಯಾಕ್ಟರ್ಸ್ ಆಫ್ 12 ಅಂತ ಹೇಳ್ಬೋದಾ? ಹೇಳ್ಬೋದು. ನಾವು ಈಸ್ 2 divides 221? ನೋ. ಕ್ಯಾನ್ 3 divide 221? ಸಿ ಚೆಕ್ ಮಾಡಿ. ನೋ. 2 cannot divide 221, 3 cannot divide 221, therefore I can easily say that 12 cannot divide 221. 12 cannot divide 221. Andre, if I say if a number divides other number, then that number should be divided by the prime factors of that number. Following? ಅರ್ಥ ಆಗ್ತಿದೆನಾ? ಈ ನಂಬರ್ನ ಡಿವೈಡ್ ಮಾಡುತ್ತೆ ಅನ್ನೋದಾದರೆ ಈ ನಂಬರ್ನ ಪ್ರೈಮ್ ಫ್ಯಾಕ್ಟರ್ಸ್ ಯಾವ್ಯಾವು? 2 3, ಅವುಗಳು ಈ ನಂಬರ್ನ ಡಿವೈಡ್ ಮಾಡಿದ್ರೆ ಮಾತ್ರ ಈ ನಂಬರ್ ಇದನ್ನು ಡಿವೈಡ್ ಮಾಡುತ್ತೆ ಅಂತ ಅರ್ಥ. Following? I am asking whether 12 can divide 221. I just find the answer in this way, in the prime factors way. So I just look at the prime factors of 12. What are those? 2 and 3 are the prime factors of 12. Now I will see, can 2 divide 221? No. Can 3 divide 221? No. ಯಾವುದಾದ್ರೂ 1 ಡಿವೈಡ್ ಮಾಡಿಲ್ಲ ಅಂದರೆ 12 cannot divide 221. ಈಗ ನೋಡಪ್ಪ, ಕ್ಯಾನ್ 242 divided by 22? 22 242 ಭಾಗಿಸುತ್ತಾ ಅಂತ ಬರಿತೀನಿ. ಈಗ ಕೇಳಿದ್ದೀನಿ. Yes, of course it can divide. How? What are the prime factors of 22? 2 and 11. That's it. 2 and 11. So this is the only way I can write 22 as prime factorized. 2 into 11. Now tell me, can 2 divide 242? Of course. 141 ja. 141 is 242. Now, can 11 divide 242? Of course. How many times? See, 242, 11. 11 2s are 22, 2, 2, 11 2s are 22. Therefore, 11 22s are 242. Therefore, 2 and 11 both can divide 242. Indirectly, I can say that 22 can divide 242. Therefore, any number can divide other number only when its prime factors can divide that number. Can divide that number. Understood? Enanta? A number can divide other number only if its prime factors can divide that number. ಅರ್ಥ ಆಯ್ತಾ? ಈಗ ನೋಡಪ್ಪ, let me take another number. ಇರಲಿ, ಇಲ್ಲಿ ಬರೀತೀನಿ ನೋಡಿ. Let me take a number such as 420, which is 420, right? ಯಾವುದು? 420. 420, in that number ends with 0 in the last. 0 in the last. ಕೊನೆಗೆ 0 ಇದೆ ನೋಡಪ್ಪ ಅಲ್ಲಿ. ಹೌದಾ? Now tell me, if this number can be divided by 10, of course it can be divided by 10. ಆಗುತ್ತೆ, 10ರಿಂದ ಭಾಗ ಆಗುತ್ತೆ. The numbers which can be divided by 10, they have 0 at the end. Now tell me, 420 can be divided by 10. ಅಂದ್ರೆ ಅಂತ ಅರ್ಥ, it should be divided by the prime factors of 10. What are the prime factors of 10? 2 into 5. That is 2 and 5 are the prime factors of 10. Now, if I want to say 10 divides 420, I have to check whether 2 divides 420 and 5 divides 420. If both 2 and 5 divides 420, then I can say it can be divided by 10. I consider a number which ends with 0. We all know that 10 divides that number. Nothing but what? 2 and 5 should divide that number. I know that 22 divides 242. Nothing but what? 2 and 11 should divide 242. That is, the prime factors of 22, that is 2 and 11, they should divide 242. 10 divides 420. The prime factors of 10 should divide 420. Therefore, any number which ends with 0, no? By our analogy, by our experience, by our sense, right? Any number which ends with 0, no? That should be divided by 2 and 5. ಬೋತ್ 2ರಿಂದ ಆಗಬೇಕು. 2ರಿಂದಾಗಿ 5ರಿಂದ ಆಗಲಿಲ್ಲಪ್ಪ ಅಂದರೆ ಕೆಲಸ ಆಗಲ್ಲ. 2 ಮತ್ತು 5 ಎರಡನ್ನೂ ಡಿವೈಡ್, ಎರಡು ಕೂಡ ಹೋಗಿ 420 ಡಿವೈಡ್ ಮಾಡ್ತಾನಪ್ಪ ಅಂದರೆ 10 ಡಿವೈಡ್ ಆಗುತ್ತೆ ಅಥವಾ 10 ಡಿವೈಡ್ ಮಾಡುತ್ತೆ ಅಂತ ಹೇಳ್ಬೋದು. Followed? I think it is easy to understand with these 3 examples. Now tell me, what's my question? ಈ 3 ಎಕ್ಸಾಂಪಲ್ ಕೊಟ್ಟಲ್ವಾ, ಇದು ನೀವು ಬರ್ಕೊಂಡು ಒಂಚೂರು ಅನಲಾಜಿ ಅಂದರೆ ನೀವೇ ಒಂಚೂರು ವಿಶ್ಲೇಷಣೆ ಮಾಡ್ಕೋಬೇಕಲ್ಲಿ ನಿಮ್ಮ ನೋಟ್ಬುಕ್ಕಲ್ಲಿ. ಈಗ ನೋಡಪ್ಪ, ಇಫ್ ಎ ಕ್ಯಾನ್ ಬಿ ಡಿವೈಡೆಡ್ ಬೈ ಬಿ, ಹಿಂಗೆ ಹೇಳ್ಬೋದ ನಾನು ಸಿಂಪ್ಲಿ ಜನರಲ್ಲಿ. ಎ ಕ್ಯಾನ್ ಬಿ ಡಿವೈಡೆಡ್ ಬೈ ಬಿ ಮೀನ್ಸ್ ಇಟ್ ಶುಡ್ ಬಿ ಡಿವೈಡೆಡ್ ಬೈ whom? ಶುಡ್ ಬಿ ಡಿವೈಡೆಡ್ ಬೈ ಪ್ರೈಮ್ ಫ್ಯಾಕ್ಟರ್ಸ್ ಆಫ್ ಬಿ. ಅದೇ ಇಷ್ಟಮಟ್ಟ 3 ಎಕ್ಸಾಂಪಲ್ ಕೊಟ್ಟಲ್ಲ, ಅದನ್ನೇ ಜನರಲಾಗಿ ಬರೀತಿದ್ದೀನಿ ಅಷ್ಟೇ. ಎ ಕ್ಯಾನ್ ಬಿ ಡಿವೈಡೆಡ್ ಬೈ ಬಿ ಮೀನ್ಸ್ ಅರ್ಥ ಏನು? ಇಟ್ ಶುಡ್ ಬಿ ಡಿವೈಡೆಡ್ ಬೈ ಪ್ರೈಮ್ ಫ್ಯಾಕ್ಟರ್ಸ್ ಆಫ್ ಬಿ. ಆಲ್ ಪ್ರೈಮ್ ಫ್ಯಾಕ್ಟರ್ಸ್ ಆಫ್ ಬಿ ಎಲ್ಲದರಿಂದ ಡಿವೈಡ್ ಆಗಬೇಕು. ಜನರಲ್ ಸ್ಟೇಟ್ಮೆಂಟು. ಈಗ ನೋಡಿ, ಅವ್ರೇನು ಕೇಳಿದರೆ 4n ನಂಬರು ಫಾರ್ ಎನಿ ವ್ಯಾಲ್ಯೂ ಆಫ್ ಎನ್ ವ್ಯಾಲ್ಯೂ ಆಗ್ತಾ ಹೋದಂಗೆಲ್ಲ 4n ನಂಬರ್ಸ್ ಬರ್ತಾವಲ್ವಾ, ಇವೆಲ್ಲ ಬರ್ತಾವಲ್ವಾ. ಇಸ್ ದರ್ ಎನಿ ಸಚ್ ನಂಬರ್, ಇಸ್ ದರ್ ಎನಿ ಅಟ್ಲೀಸ್ಟ್ 1 ನಂಬರ್ ವಿಚ್ ಎಂಡ್ಸ್ ವಿತ್ 0? ಅಂದರೆ ಕೊನೆಗೆ 0 ಇರುತ್ತಾ, ಇರ್ಬೋದು ಅಂತ ಕೇಳ್ತಿದ್ದಾನೆ. ಸಪೋಸ್ 4n ಎಂಡ್ಸ್ ವಿತ್ 0 ಅಂದ್ಕೊಳ್ಳೋಣ, ಇದೆ ಅಂತಂದು 0 ಇದೆ ಅಂತ. ಕೊನೆಯಲ್ಲಿ ಯಾವುದೋ ಒಂದು 4n ನಂಬರಲ್ಲಿ ಹಿಂಗೆ ಬರ್ತಾವಲ್ವಾ, ಯಾವುದೇ ಒಂದು 4n ನಂಬರಲ್ಲಿ ಕೊನೆಗೆ 0 ಇದೆ ಅಂತ ಹೇಳೋಣ, ಇದೆ ಅಂತ ಅನ್ನೋಣ. ಅಂದ್ರೆ ಏನರ್ಥ? 4n ಶುಡ್ ಬಿ ಡಿವೈಡೆಡ್ ಬೈ 10 ಅಂತ ಅರ್ಥ. 420 ನೋಡಿದಲ್ವಾಗಲೇ 10ರಿಂದ ಆಗಲೇಬೇಕು, ಅವು ಮಾತ್ರ ಕೊನೆಗೆ 0 ಇದೆ ಅಂತ ಹೇಳ್ಬೋದು ನಾವು. ಇಲ್ಲಿ ಈ 4n ಎಂಡ್ಸ್ ವಿತ್ 0, ವಿ ಹ್ಯಾವ್ ಟೇಕನ್ ದಟ್. ಸಪೋಸ್ 4n ಎಂಡ್ಸ್ ವಿತ್ 0 ಅಂದರೆ 4n ನಂಬರಲ್ಲಿ ಯಾವುದೋ ಒಂದು ನಂಬರಲ್ಲಿ 0 ಇದೆ ಲಾಸ್ಟ್ಗೆ ಅಂತ ಅಂದ್ಕೊಳ್ಳೋಣ. ಅಂದರೆ ಏನು? ಶುಡ್ ಬಿ ಡಿವೈಡೆಡ್ ಬೈ 10. ಇನ್ ಅದರ್ ವರ್ಡ್ಸ್, ಶುಡ್ ಬಿ ಡಿವೈಡೆಡ್ ಬೈ 2 and 5. 2 and 5 ಡಿವೈಡ್ ಆಗಲೇಬೇಕು. ಯಾವುದು? 4n ನಂಬರ್ಸ್ಗಳು. ಅವಾಗ ಮಾತ್ರ 10 ಡಿವೈಡ್ ಆಗುತ್ತೆ. ಅವಾಗ ಮಾತ್ರ 4n ಕೊನೆಗೆ 0 ಇದೆ ಅಂತ ಅರ್ಥ. 2 ಮತ್ತು 5 ಎರಡು ನಂಬರ್ಗಳು ಯಾವುದೇ ಒಂದು 4n ನಂಬರನ್ನು ಡಿವೈಡ್ ಮಾಡಬೇಕು, 2 ನಂಬರ್ ಡಿವೈಡ್ ಮಾಡಬೇಕು. ಅವಾಗ 10 ಆ ನಂಬರ್ನ ಡಿವೈಡ್ ಮಾಡುತ್ತಂತ ಅರ್ಥ. 10 ಡಿವೈಡ್ ಮಾಡಿದರೆ ಕೊನೆಗೆ 0 ಇದೆ ಅಂತ ಅರ್ಥ. ಫಾಲೋಡ್ ರೈಟ್? ನಾವು ಟೇಕ್ ಎನಿ ನಂಬರ್ ಇಯರ್ 4ನ ಪ್ರೈಮ್ ಫ್ಯಾಕ್ಟರ್ಸ್ ಯಾವಪ್ಪ? 2 into 2 ಯಾವಪ್ಪ? 2 into 2 into 2 into 2. ಇಲ್ಲ ಅಷ್ಟು 64 ಹೆಂಗೆ ಬರೀತೀನಪ್ಪ ನಾನು? 2 into 2 into 2 into 2 into 2 into 2 ಸಾರಿ 2 into 2 1 2 3 4 5 6. ಸೊ ಪ್ರತಿ ನಂಬರಿಗೆ 2 ಜಾಸ್ತಿ ಬರ್ತವೆ. Now tell me, in the prime factorization of all these 4n numbers, is there any 5 here? 2 is the only prime number which comes in the prime factorization of 4n numbers. They do not have 5 here. ಇಂಥವುಗಳು ಎಲ್ಲ ಬರೀ 2 2 2 ಮಾತ್ರ ಹೊಂದಿರ್ತವೆ, 5 ಬರೋಕ್ಕೆ ಚಾನ್ಸೇ ಇಲ್ಲ ಅಲ್ಲಿ. Therefore, in the prime factorization, that is in that expression, no 5 will be there, indicating what? 5 cannot divide any 4n number. Cannot divide any 4n number. Therefore, what I said, a number, 4n number, if it ends with 0 means it has to be divided by 2 and 5. In other words, in any expansion, what expansion? Prime expansion of that number 4n. ಯಾವ ನಂಬರ್ ತಗೊಳ್ಳಿ, in the prime expansion 2 and 5 should be there, both should be there, but only 2 is there. In all the numbers only 2 comes here, no 5 comes. 5 cannot come here. Therefore 5 cannot divide any 4n number. If any one of them doesn't divide 4n means it cannot be divided by 10. If it is so, it doesn't have 0 at the end. It doesn't have 0 at the end. Therefore I can write like this: prime factorization of any 4n ಅಂದ್ರೆ ಇವು any 4n, prime factorization of any 4n, prime factorization of any 4n contain only 2, contains only 2, not 5. That's why 5 cannot divide any of these numbers. If 5 cannot divide means 10 cannot divide. 10 cannot divide means there is no 0 at the end. There is no 0 at the end. ಇದನ್ನಿಷ್ಟೆಲ್ಲ ಸರ್ಕಸ್ ಮಾಡಬೇಕಾ ಸರ್? ಡೈರೆಕ್ಟಾಗಿ ಹೇಳ್ಬೋದಾ? ಡೈರೆಕ್ಟಾಗಿ ಥಿಂಕ್ ಮಾಡ್ಬೋದಾ ಅಂದರೆ ಥಿಂಕ್ ಮಾಡ್ಬೋದಪ್ಪ. ಇಲ್ಲಿ ನೋಡಪ್ಪ, ಇಲ್ಲಿ ಏನಂತೆ, ಸಪೋಸ್ ಈ 4n ends with 0 ಆ ಥರ ಡಿವೈಡ್ ಆಗಬೇಕು, ಅಥವಾ 2 ಮತ್ತು 5 ಇಂದ ಡಿವೈಡ್ ಆಗಬೇಕು ಆ ನಂಬರ್. ಹೌದಾ? 2 ಮತ್ತು 5 ಇಂದ ಎರಡರಿಂದ ನಾವು ಡಿವೈಡ್ ಆಗಬೇಕು. ಈಗ ನೋಡಪ್ಪ, ಇಲ್ಲಿ ವಾಟ್ ಇಫ್ ಐ ಎಕ್ಸ್ಪ್ರೆಸ್ 4n as 2 into 2n ಮಾಡ್ಬೋದಾ? Now tell me, is there any way such that I can express 4 as 2 into 5? ಈ ಎಕ್ಸ್ಪ್ಯಾನ್ಷನ್ ಅಲ್ಲಿ ಈ ಥರ ಎಕ್ಸ್ಪ್ರೆಸ್ ಮಾಡಿದಾಗ 4n now it is 2 into 2 whole to the power of n. Is there any chance that I can express 4 as 2 into 5? No chance. Or 5 into 2? No chance. This expansion, this inner expansion, no, as only 2. We can say that 2 is the only prime number in the prime factorization. No other number can come here. So indirectly you can say that, directly you can say that 5 is not here. In the expansion, what's that? 4n is equals to 2 to n. In this expansion, no 5 is there. Therefore, 5 cannot divide any 4n number. n cannot divide that number. There is no 0 at the end. Our supposition is wrong. That is, no such number is there. No such 4n number is there which ends with 0. That is, no value of n cannot exist. I mean, no value of n is there. No value of n is there such that 4n number ends with 0. ಅಂತ ಅರ್ಥ. ಅಲ್ಲಿ ಅರ್ಥ ಆಯ್ತು ಅನ್ಸುತ್ತೆ. ಭಾಳಷ್ಟು ಇದ್ರ ಮೇಲೆ ಟೈಮ್ ಸ್ಪೆಂಡ್ ಮಾಡಿದ್ದೀನಿ. ಹೌದಾ? ವಾಟ್ ಇಫ್ ಐ ಆಸ್ಕ್ ಅ ಕ್ವಶನ್ ಲೈಕ್ ದಿಸ್? ಇದು ಡೈರೆಕ್ಟ್ ನೋಡೋದಪ್ಪ. ಈಗ ನೋಡಪ್ಪ, ಇನ್ನೊಂದು ಅವರು 4n ಕೇಳಿದ್ರೆ ನಾವು 3n ನೋಡೋಣ. Is 3n ends with 0? Is any 3n number ends with 0? What are 3n ಅಂದ್ರೆ? 3n ಅಂದ್ರೆ ಏನಪ್ಪ? n 1 2 3 ಹಾಕಪ್ಪ. ನೋಡಪ್ಪ, ಇಲ್ಲಿ 1 ಹಾಕು 3 ಬಂತು, 2 ಹಾಕು 9 ಬಂತು, 3 ಹಾಕು 27 ಬಂತು. ಹೌದಾ? 4 ಹಾಕು 81 ಬರುತ್ತೆ. ಹಿಂಗೆ ಬರ್ತಾ ಹೋಗ್ತವೆ. ಇವೆಲ್ಲವೂ 3n ನಂಬರ್ಸು. ನೋಡಿ, ಎಲ್ಲಿ ಕೂಡ 0 ಇಲ್ಲ, ಲಾಸ್ಟಿಗೆ 0 ಬರೋದು ಇಲ್ಲ. ಅಲ್ಲಿ ಹೆಂಗೆ ಡೈರೆಕ್ಟಾಗಿ ಹೇಳಬೇಕು? ಸಿ 3n. Is there any way such that I can write 3 as 3 into 5? ಚಾನ್ಸ್ ಅಲ್ಲಿ 15 ಆಗ್ಬಿಡುತ್ತೆ. 3 ಹೆಂಗಾಗುತ್ತೆ? 3 ಆಗ್ಬೇಕಂದ್ರೆ 5 ಯೂಸ್ ಮಾಡ್ಕೋಬೋದ ನಾನಲ್ಲಿ? ಐ ಕ್ಯಾನಾಟ್ ಯೂಸ್ 5 ಇಯರ್. ಇಫ್ ಐ ವಾಂಟ್ ರೈಟ್ 3 as 3, only way is 3 only. The only way that I can write 3 as 3 is only 3. Now, ಹಾಗಾಗಿ in this expansion, no 5 is there. No 2 is there. If I want to see whether 3n ends with 0 means it has to be divided by what? 2 and 5. 2 ಮತ್ತು 5ರಿಂದ ಬಾಗ್ಲು ಆಗಲೇಬೇಕದು. In this expansion, no 2, no 5. 5 ಇದ್ರೂ ಕೂಡ 2 ಇರಬೇಕು, 2 ಇದ್ರೂ ಕೂಡ 5 ಇರಬೇಕು. 2 ಇರಬೇಕು, ಆಗಲ್ಲ. 6n ends with 0. Now I can expand 6 as 2 into 3. Now tell me, in this expansion 2 is there but not 5. Therefore 6n doesn't have, no 6n cannot have 0 at the end. I mean, no 6n can have 0 at the end. ಅಂದರೆ ಯಾವುದೇ 6n ನಂಬರು ಕೊನೆಗೆ 0 ಇರಲ್ಲ. 7n, the only way is 7 only. No 2, no 5 in this expansion. In this, in this region. 8n, 2, 2, 2. 2 is there but no 5 is there. No 5 is there. Therefore, no 8n number as 0 at the end. Now, take nn. Here comes our magic. 10n ba. ಇದೇನಾಗುತ್ತೆ ನೋಡಿ ಈಗ. Look at the 10n. 10n ಅಂದ್ರೆ ಏನು? ಒಂದಕ್ಕೆ ಎನ್ಗೆ 1 ಹಾಕಪ್ಪ 10 ಆಯ್ತು, ಎನ್ಗೆ 2 ಹಾಕಪ್ಪ 100 ಆಯ್ತು, ಎನ್ಗೆ 3 ಹಾಕಪ್ಪ 1000 ಆಯ್ತು, ಎನ್ಗೆ 4 ಹಾಕಪ್ಪ 10,000 ಆಯ್ತು. ಹಿಂಗೆ ಹಾಕು 1,00,000 ಆಯ್ತು. ಓಕೆ. These are all 10n numbers. 10n numbers. Now, is there any number which ends with 0? Of course, all number ends with 0. How can I say expand this? 10 can be written as 2 into 5. That is, if I just expand or if I just prime factorize 10, 2 into 5. Therefore, in this expansion, I have both 2 and 5. Therefore, I can say that 10n numbers as 0 at the end. That's it. That is for the children. So, in this class, let this be enough for this class. So, in the next class, we talk about LCM and HCF. You all know how to calculate LCM and HCF of any two numbers. You all have learned that in your earlier class using prime factorization method. But you are all calculating those HCF and LCM using FTA only, fundamental theorem of arithmetic only. Without knowing it, ಅದು ಯೂಸ್ ಮಾಡ್ತಿದ್ದೀರಿ ಅಂತ ಗೊತ್ತಾಗದೇನೆ ಇಷ್ಟು ದಿನ ಕಲ್ತಿದ್ದೀರಿ. So we talk about LCM and HCF using FTA in the next class. Until then, bye bye.